Hello everyone, welcome to IAS Baba's 60 days rapid revision series for Prelims 2022. This is day 19 and we take up geography topics. So these are some of the topics that we are going to discuss today. So first we take up different forms of condensation. Friends, we have always a confusion like which is a form of condensation, which is a form of precipitation, so all those things. So here we get a clear idea here. So first one, the form of condensation is the dew. So in the early morning, so we will see that, and if you are seeing IPL matches, so in the night, so the dew starts coming. So it is a form of condensation, not a precipitation. So mark that. So here, when the moisture is deposited in the form of water droplets on cooler surfaces of solid objects rather than the nuclei, so here the dews are being formed. Say for example, in the cloud formation, what happens? So it is like around the condensation nucleus, the water droplets they get accumulated. So here instead of condensation nucleus, so here the surface is used for condensation. So that is the difference between a condensation and a precipitation here. So the condensation is happening, not precipitation. Then come to next, the frost. So here the same condensation happens on the surface, but here the surface is below the freezing point. So only that is the difference. And whenever the surface is below freezing point, so instead of forming a dew, it forms a crystal of ice, that is the frost. And then come to next, the haze. So haze is another form of condensation. So here it is like we don't get the water droplets or the ice crystals, only that we will feel some murky air. So the atmosphere, it becomes unclear and murkier. So here it is like whenever the air that is carrying moisture, so that cools down. So here we will get the haze. So the moisture is not so strong. So the moisture is not in enough content so that it will form a mist or it will form a fog. So a very light murkier, so that forms the haze. So something like a smoky type atmosphere. So it is not smoke. These are the water minute droplets. And if the moist air, if it has more humidity, then that will give rise to this fog. So the same air, if it has a less, it gives a haze, and if it is having more humidity, it gives a fog. Okay, so fog is more murkier. So here we can't see the farer objects also. So in Delhi and other regions, so in winter, whenever there is so much of fog, so the accidents occur in the highways because these people who drive, they won't find the objects coming from the other side. Okay, then come to next, the mist. So if the air contains more humidity, so then the mist is formed. So maximum, and here the mist is always so hazy that we will feel that the clouds themselves have come down. So if you go to Western Ghats, so on the hilltops during rainy season, you will find these mists. So it is like completely the translucent, or we can say completely opaque air for that matter. And then come to next, the forms of other condensation is the cloud. So this is the actual one. So here the whatever condensation happens, so that happens in the above atmosphere. So here it is like as and when the wind that is carrying the moisture, so when it rises up, so it expands. So whenever it expands, it cools adiabatically. So adiabatic cooling means expansion by volume. So whenever it cools, so there the cloud formation occurs. Then come to next, rain. So this is a form of precipitation. So here a small difference between precipitation and condensation is that, so once the dew point is achieved, so the condensation will occur, but if the collection of moisture is huge, so then the threshold of the amount of moisture a condensation nuclei can hold or any surface can hold, if that is reached, so it starts shredding down. So if the condensation nuclei holds more number of moisture, so it becomes heavy and it falls down. So precipitation is only that there is excess of moisture and the condensation point has reached and the moisture has grown in excess. Then come to next, the rainfall. So here the rainfall is a form of precipitation. Then what is the difference between condensation and a precipitation? Say for example, here in the condensation, the dew point is achieved and then the water droplets they form occurring. So water droplets they accumulate. Okay, say for example, they accumulate around a condensation nuclei, but more and more droplets they accumulate and now the condensation nuclei becomes heavy and that falls down. So that is the difference between the condensation and precipitation. So here in the condensation nuclei, it hasn't reached that threshold capacity, but here it has reached that threshold capacity. So in the rainfall, whenever the condensation, so it is reached and whenever the humidity is huge that the condensation nuclei have exceeded capacity, so the rain droplets they fall. Then come to next, the snowfall. So here it is very similar to the rainfall, but here that as and when the temperature of the air, so it is below freezing point, so instead of raindrops, we start getting snowdrops. So friends, here the crystals will not be formed. So it is like the small snow droplets, so they will be formed. So whenever we see the snowfall, so here we will see the milky whitish color. We won't see the transparent ice crystals over there. Okay, so that means the ice falls in the form of small droplets. Okay, so like this, the crystals will not be formed here. Then come to next, sleet formation. Friends, here there is a small difference. Say for example, here the low surface is having very cold air, and here in between we have some warm air, and above again we have a cold air. So whenever the snowfall is coming down, so whenever it encounters a warm air, so here the snow droplets, they liquefy and they fall as water droplets on the surface. But again, when they fall on the surface here, so they will have to solidify because it is a cold air. So now they will form as ice crystals like this. Okay, so they form a transparent ice crystal, and the shape of the crystal will be as same as the surface on which they have fallen. So that means the water droplets have fallen first and then they have liquefied. So here it is a form of a precipitation sleet. It is not a form of condensation. So make sure that this structure of cold, warm and cold air, so you will remember. Then come to next, the hailstorms. So hailstorms you already know. So these are formed by the cumulonimbus clouds. So whenever the clouds, so inside that the air droplets, they toss up and down. So in that context they freeze, and as and when they become heavier, so they fall as the hailstones. So Kalbaisak, so all these we get the hailstones more. So then come to next, the drizzles. So drizzles are a part of precipitation. So here instead of the large water droplets, so here less than 5 millimeters of diameter water droplets we will be having. So small drizzles. So these are common everywhere. I don't think for this we require a separate explanation. And then the snow grains. So here this snow grain, it is like the snow grain is a frozen drizzle. So as and when the drizzle comes, so if those drizzles froze down, so there we will have the small grains, the small droplets of the snow. Okay, so this is like the crystals here. So these are much larger when compared to the actual snowfall. So in the actual snowfall, the grains will not be formed. So here the grains will be formed. Okay, so this is a small difference between the snowfall and a snow grain. Then come to next, the air masses. So air mass is present in NCERT and it was also asked once in UPSC mains. So that is why I have brought it. So air mass is a large parcel of air whose horizontal variation in physical properties such as temperature, humidity, etc. is almost negligible or very little. Say for example, if this is the area, so the air column present here, so they have little changes as we move horizontally. And then air masses are spread over an area of thousands of kilometers. So this area is about thousands of kilometers. It might be a continent, or it might be a group of nations. So that much of area. Then the region where the air masses originate is called the source of origin of air mass. So here I have the map where the various air masses. So here we have the equatorial air mass. So equatorial air mass. So here we have mostly the marine. So that means marine equatorial air mass. So they are present on the oceans. That's why except some small pieces of land. So throughout we have oceans. And then we have the continental tropical air masses. So here on the continents we have the tropical air mass, that too in the tropical. Then we have marine tropical air mass. So that means on the oceans. And then we will get the polar. So polar means the continental polar and maritime polar. So both are present. So on the basis of the land and the ocean, so marine or continental will be differing, and basis of the latitudes we will define whether they are tropical, polar or anything for that matter. Okay, so this is a simple concept. Then come to next, adiabatic lapse rate. So here the change of temperature with a change in the altitude of an air parcel without gaining or losing any heat to the environment surrounding the parcel. So this is the adiabatic heat. So that means like when the air rises above, so without giving or taking any heat, so it will be cooled. So that means just by increasing the volume, it will cool on its own, but no exchange take place between the air mass and the outside. So here the dry adiabatic lapse rate, it is that a dry parcel of air, so that cools by 3 degrees Celsius whenever it rises for every 100 meters in the altitude. So every 100 meters rise means every 3 degrees Celsius of cooling occurs. And then wet adiabatic lapse rate. So here the wet adiabatic lapse rate means the lapse rate of a humid air or the moisture carrying air. So that is 6 degrees Celsius per 1000 meters. So even if it crosses 1000 meters, it cools for only 6 degrees Celsius. So here the reason, because like whenever the moist air rises up, so the latent heat of the water vapor that is present, so that will be released to the external environment. So that will warm that air. So here the cooling will not happen because that latent heat will be keeping on warming the air. So remember the dry adiabatic lapse rate, so that is 3 degrees Celsius per 100 meters, and then the wet adiabatic lapse rate is 6 degrees Celsius per 1000 meters. Okay, so this is much less compared to this one. Then come to next, the atmospheric pressure and the wind system. So we have already studied this. So here we have the low pressure area in the tropics, and then we will be having a high pressure, and then again a low pressure area in the subpolar regions. So all these, and here in the tropics we have the trade winds. Okay, and then we have the temperate westerlies, and again we will be having the polar easterlies. So all these. So here how the questions will be framed and how you will answer. So whenever the conceptual questions are being asked, so how you will take the evidence based guesswork or the evidence based analysis. So going with this question, in the tropical zone, the western sections of oceans are warmer than the eastern sections owing to the influence of trade winds. Okay, so here we take the Pacific Ocean. So in the Pacific Ocean, here we have the South America, and then here we have the Asia Australian coast. So the trade winds in the tropical zone, they will be moving from the east towards the west. So like this. So as and when they move from east towards the west, so here they create vacuum, and here the cold waters, they will upwell. Okay, like this. They upwell, and here this area, that is the eastern part, will be cooler than the western part. So we will read the statement with that example. So here the western sections of the oceans are warmer than eastern sections. Yes, so if these are cooler than these, so then these western sections are warmer than the eastern sections. The statement stands to be correct. Then in the temperate zones, the westerlies make the eastern sections of oceans warmer than the western sections. So now you take one more example, you take Atlantic Ocean. Okay, so Atlantic Ocean, so the temperate of Atlantic Ocean we take here. So it is like the Newfoundland and then the Canadian coast, so that will be this side, and Europe will be this side. So now we make sure that the westerlies are blowing, so here from west to the east direction. So here we come across the Gulf Stream. So that Gulf Stream, that will carry the hot water, and this will be carried towards the Norway. So we know that Norwegian current. So the Norwegian current brings the warm water, and that is why it is the liquefying the ports of Norway, and that is why because of Norwegian current, the Norwegian ports will work even in winters, else they would have been freezing cold. So now we will compare this example with the statement, in the temperate zone, westerlies make eastern sections of ocean waters warmer than the western section. Yes, so this is the eastern section, and now they are making warmer. The westerlies, they influence the path of the ocean current, and they are making it warmer than the western one. Okay, so now the statement 2 also stands to be correct. So with the help of evidence, if you approach this, then there will be no problem at all. Else friends, if you go crudely, then you will make more wrong in the conceptual questions. So that will hurt your precision and also the marks later. Then come to next, the heat dome in Canada. So recently the Pacific Northwest and some parts of Canada recorded the temperatures around 47 degrees. So causing a historic heat wave. And this is a result of phenomenon referred to as the heat dome. So now we discuss how the phenomenon of heat dome occurs. So here it is like a heat dome is an area of high pressure that passes over a region like a lid on a pot. So here there will be a high pressure wind. So high pressure wind will always be a descending wind. Okay, so whenever the wind descends, so here, so it will trap the warm wind so below it, so thereby forming a pot like this, and this high pressure winds, they will act as a lid for this pot, so thereby the heat dome will be occurred. So here we will see how this actually occurs. Say for example, there is a La Nina. So in the La Nina times, so here the western coast of the Pacific Ocean, so they will be warmer, and the eastern coast of Pacific Ocean, they will be colder. So here the air will be rising, and here it will be forming. So whenever the air is falling here, so it is like these are the high pressure winds, and now here in this part, the ocean will be heated, and as and when the ocean gets heated in the western part, so these heat air, so that will be carried, and here we will be having so many jet streams. So these jet streams, they push the warm air towards the continent, and as and when they are pushed towards the continent, so here we have the high pressure air, so that will always push this hot air downwards. So as and when it pushes downwards, so here the heat will be trapped. Okay, so during the times of La Nina, so it will occur maximum because so during the La Nina times itself, so here the heat and cold of the Pacific Ocean will be conducive for them. So this is how the heat dome occurs. Then come to next, the discrete auroras of Mars. So just like how we have auroras in the Earth, so the same way the UAE's Hope spacecraft, which is orbiting Mars, has captured images of glowing atmospheric lights known as the discrete auroras. So here the uniqueness of these auroras are, unlike the auroras on the Earth, which are seen only near the North Pole and the South Poles, the discrete auroras of Mars are seen all around the planet at the night time. So here we will have a brief discussion on auroras. So say for example, here we have Earth. So whenever the solar wind comes, so Earth has a magnetic field which is strongest in the North Pole and South Pole. So these solar winds, so they will be attracted towards these poles, and here when they come in contact with the ionosphere and the magnetic field, so they will give different colorful plumes. So that is why in the North Pole and South Pole we will be having the auroras. But here in the Mars, so the UAE's spacecraft, so it is saying that so we will be having the auroras all over the Mars, not only at the poles. So that means there is a problem in the magnetic field of the Mars, and the magnetic field of Mars is not strongest in its poles. So that is why the auroras are formed throughout. So that if you remember, so that is more than sufficient. And remember how these auroras are formed. And then the types of clouds. So here we have the cirrus, stratus and cumulus clouds. So those are the basics, and apart from that, here we have many other types, that is the cirrus and the cirrus stratus. So cirrus stratus means so there will be feathers, but at the same time they will extend to form a layer like thing. So they are present in the high level of atmosphere. And then the cirrocumulus. So here also we have the cumulus clouds means so they have some vertical depth also. So but they are also present in the upper part of atmosphere. That's why they are called cirrocumulus. So anyway, these will not bear any rainfall because they are too small in nature. And then we have altocumulus. So here also they have, the cloud has some vertical height here. But however, this altocumulus, so even though they are present in the mid latitude, so they won't bear so much of rainfall. Then we have altostratus. That means the stratus layer present in the mid latitude. And then the cumulonimbus, but obvious we have learned this. And then the nimbostratus. So nimbostratus means it is present in the lower and mid area, but it is nimbo. Nimbo means the cloud bearing. And then the stratocumulus. So stratocumulus means so it is a layer, but it has certain thickness also. Then stratus means it is having only the layer, and cumulus means it is just a collection of cloud. Okay, so various types of clouds, so we have discussed with graph. So preserve this picture and make sure that you will revise from this one. Then come to next, the sudden change in the direction of glaciers. So scientists have recently found that nearly 20,000 years ago, a large Himalayan glacier abruptly changed the course over time, fused into an adjacent glacier in present days Pittorgarh, Uttarakhand. So in Uttarakhand, Pittorgarh, so the change of direction has occurred. So it is a simple concept, that is with the help of tectonics or due to the presence of any other glaciers, or maybe due to the change of course of that glacier, the glacier might have changed its course. So here the causes of the change, that is change in the climate and tectonic movement can be one. Then its accumulated debris caused it to turn from the northeast direction into the southeast course. So here, that is if there is any deposition and if it blocks the way, so then the glacier has to turn it out. Then come to next, the tropical cyclones. So the favorable conditions for a tropical cyclone. So here a source of warm moist air derived from the tropical oceans with a sea surface temperature normally in the region of the 27 degrees Celsius or in excess. So here a warm moist air with the high temperature and low pressure in between. So we know that for a tropical cyclone, so low pressure, high temperature in between, followed by the high pressure and low temperature in the surroundings. Then the winds near the ocean surface blowing from different directions, converging and causing the air to rise and storm clouds to form. So as and when we have the high pressure in the surroundings, so here we will be having that whirling, as these high pressure clouds, they will converge. Then winds which do not vary greatly with height, known as the low wind shear. So this low wind shear is somewhat tricky. So here we will discuss how this low wind shear. So here vertically speaking, there should not be a great pressure gradient for the wind. Say for example, if there is a great pressure gradient like this, so the air will suddenly rise vertically. So there will be no chances of swirling. But if the gradient is less, or if the gradient is small in these small bits, so here as and when the wind rises to this area, so it will be trapped to some time in this, and then it takes time to move here. So as and when it takes time, so here it gets some opportunity to swill and then move to the next one, swill and move to the next one. So likewise, so remember this very importantly, that there should be a wind shear which is very low. So high wind shear is not conducive for the rise of cyclones or the swirling of the cyclones. Okay, and then sufficient distance from equator to provide the spin or the twist. So here this is required for the Coriolis force, that is the cyclones, they should move as per the Coriolis force. And then so here we can see, here have some importance towards the temperature. Okay, so temperature, so they have to be more in the eye of the cyclone. Okay, so mark this as important. So in the last prelims 2020 there was a question on temperature also, but pressure should be less in the eye. Okay, so pressure P1 and P2, so that should be less in the eye. Okay, so here the eye, so eye should be cool and calm, there should not be so much of disturbance in the eye. So in the middle, so this one, it should be cool and calm. Okay, so these are some of the things regarding the tropical cyclones. Then come to next, the formation of fronts. So in the temperate cyclones, so they are formed mainly by the formation of fronts. So here fronts can form in two ways, like when the cold air and warm air, so when they come face to face in the opposite directions and whenever they collide. So this is also one area where the cyclones can form, or in other words, whenever they have a front like this, that means a cold air and a warm air, so they are moving sideways, so they are not having a head-on collision, even then it can occur. So here, say for example this one, so here cold air and warm air, so they are moving sideways, but here as and when they move, so it can turn towards a rotation and not a parallel movement. So whenever they turn towards rotation, so then this is obtained. So here that warmness will be trapped here, so this will give rise to a warm in middle and the cold around. So very similar to a tropical cyclone. Now the cyclone can occur. So here the brief diagram of how the warmness will be trapped and how that gives rise to cyclone. So that is given here for both the northern hemisphere and the southern hemisphere. So this is how when the winds are moving sideways, so how the fronts will be formed. But apart from this, even if the head-on collision occurs, so then also we can have the temperate cyclones. Say here for example the head-on collision is happening. So here the cold air, so that is there and the warm air is there. So the cold air will advance and it will suddenly lift the warm air. So in this area the precipitation occurs. Okay, and then here we have the cold air which is stagnant and warm air rushes. So as and when the warm air rushes, so here this warm air will not be static in this area, so it will spread. So that means if the warm air is causing the lift off, so here it is like the precipitation spreads for longer distance. Okay, but if the cold air is causing that lift off, so here the rainfall will be concentrated, so only to some part of the region. And then we have the occluded front here. So here the cold air will be there and here also a cold air will be there. But in between these two cold airs, some warm air will be lifted off. So here also the rainfall can occur in this area. Okay, so this is how when the fronts are formed both the sideways and also in the head-on collision. So both the ways, so we can get the temperate cyclones. Then come to next, the tropical and monsoon climates. So here the tropical climate, so all 12 months have a temperature of warmer than 18 degrees centigrade. Okay, so this is the temperature and it is constant. Like there is no variation in the temperature in tropicals. And then precipitation is also throughout the year. So how you will make sure that the precipitation, so mark it as some 0 to 200 scale, and in that 100 centimeter will be the average precipitation in tropical and it will be constant throughout the year. And here in the temperature, so here mark it as 18 degrees Celsius. Okay, then the tropical climates are basically frost free and in the solar angle, so the changes is very small. That means the solar radiation is also constant throughout the year. Then the climate there is tropical, meaning to say it is very hot and humid in temperature. So this we already know. So here remember the 18 degrees Celsius and 100 centimeters of average rainfall. And then the tropical monsoon climate. So here it is like this type of climate occurs because of monsoon winds which changes its direction. So we know that India is a typical monsoon climate, and then in this kind of tropical climate there is a short and distinct dry season. So this dry season is not present in the other tropical areas like the Congo, Brazil and others. Then therefore this one comes under the influence of intertropical convergence zone. So there was one question in prelims, that is, which is the most important causative factor for the formation of monsoon, that is the shifting of ITCZs. So mark this as important. Then under the influence of drier trade winds at the time of low sun, so basically the winters occur. So here they are speaking of the northeast winds, so which cause the cold and dryness on the India. So such winds, so they will flow during the dry seasons. Okay, so here it is like the monsoons. So here apart from that short dry, so we will be having rainfall in most of the months. So that is the only difference between the tropical and tropical monsoon climate. So here whenever you study these ones, so make sure that you have your own temperature and precipitation lines. So take it as -10 to say 40 degrees Celsius. So above 40 degrees Celsius no biome can survive. So this as the maximum. So your temperature should be within this range. Say for example 18 to 20 degree, that is the tropical here. And then if you are searching for temperate, so here have a range. So here in winters, so that can go up to 10 degrees Celsius, and in summers it can go up to 30 degrees Celsius. So likewise you alter whenever the biomes change or whenever the climatic zones change. And even for precipitation you can take from 0 to 200 centimeters. So say for example Meghalaya we have 400 centimeters, so that is extreme. So 200 centimeters is the normal one. So we have taken 100 centimeters of rainfall for tropical. So for the tropical monsoon, so you can have a range, like in summer we can have 140 centimeters, in the dry seasons so it is below 70. So likewise, so like these ranges if you have, you need not by heart, you will get an idea of how to predict the questions if they come in prelims. Then the temperate climate zone, is characterized by, so they have 4 well differentiated seasons. Okay, so summer, winter, autumn and spring, and then they get seasonal rainfall, that is in the rainy season. Then allow the development of wide variety of vegetations. So here a good variety of vegetations are present like the grasslands and others, but we know that the maximum diversity is present in tropical and not in temperate. And then they are present in the temperate zones. A brief, and here make sure that the temperature line, so that is say from, for example, from 10 degree to 30 degrees Celsius, or you can bring it down also. So 25 degrees Celsius you can write it here. And the precipitation, so 80 centimeter will be the average. So in temperate the rainfall will be less compared to tropical or tropical monsoon. Then come to next, the east coast and the west coast climates. So as and when we move towards the temperate, so here we will be having these two kinds, that is east coast and west coast. Friends, in the Köppen classification the same is considered as CFA and CFB. So these are the ones which we are discussing. Then first we begin with the temperate west coast type. So here the summers are warm and dry, when the winters are mild and wet. So here the rainfall is in winters, okay, so not in summers. So we have a dry summer there and the wet winter. And then the region comes under the influence of westerlies in the winter. So it is like as and when the westerlies blow, so they blow from ocean to land and they carry moisture, and as and when they carry moisture they give the rainfall. So that is why they have the rainfall during winters. Okay, then come to next, the east coast climates. So here in these climate regions the summer are warm and winters are mild. So that means, so here the winters are bit colder and the rainfall occurs all year round, but mostly in summer. So we take that here the rainfall are in summer, not in winter. So here it is because, so it is because of the trade winds. So trade winds, we know that they blow from the east to west, and that is why they blow and they will bring moisture, especially during the summer season. Okay, so here like the west coast climate, so that is under the impact of westerlies. That is why they have the rainfall in winters, and these they have the impact of the trade winds. So that is why they have the rainfall during summers. So here the Mexico, so Gulf of Mexico, that is the best example for the east coast climate. Okay, so remember these two. Then come to next, the tundra region and the polar vortex. So the tundra climate region located between 60 degrees and 75 degree latitude. So but obvious in the subpolar region, and in such areas winters are long and cold, and winter precipitation is by snow, and during the summer cyclonic storms develop which yields rainfall. So here also we get some amount of rainfall. So here in tundra we mostly get the sedges and mosses as the vegetation. So remember the rhododendrons, sedges and mosses. So this is how the hierarchy goes. First comes the rhododendrons, and as when we move polewards, then comes the sedges, and as and when we move polewards again, so then comes the mosses. So remember this hierarchy. And here coming to how these polar vortex are formed. So here the polar vortex is an area of low pressure and extremely cold air that swirls around the Arctic. So here we have this low pressure wind, so that is flowing like this, and sometimes it will break down and it will enter to the Canada and sometimes even to USA. So this chilling cold wind, so as and when they break down and come down, so they cause the polar vortex. So disturbance in the jet streams and the intrusion of warm air can disturb this polar vortex, sending Arctic air south into the mid latitudes. So here it is like, friends, in this region that cold air will be swirling on its own, but due to global warming, so this area will be warmer, and the jet streams, so they will also be blowing like this. So whenever this warming is stopped by these warm airs and the jet streams, so this circle or the belt of movement of air, so that will be cut. So once the belt is cut down, so here the whole air, so that will be disturbed and they will rush into wherever space they have. So now they have a space here, so that means they have a way to flow southwards, and when they flow southwards, so that brings the chilling cold, bone chilling cold for the American and Canadian people. So remember the action of jet streams and the global warming. So this is also one of the causes for the polar vortex, because the heat present here, so that is what intriguing the rotating cold winds in the polar region. So these are in crude how the phenomenon occurs. So overall, if you have a conceptual clarity, so then you can tackle a number of questions for that matter. Okay, then coming to the last part, friends, if a life has to be happier and meaningful, so we have to have the success. So no life will be happier if there are more failures and compromises. So whenever you fail, so don't go for that compromise. So compromise is the sin that we do. So even if you fail, so try again and again and try for the higher ones. So once you achieve that, so might be the life will be more fruitful than you have thought out. So Abraham Lincoln, he had failed in many lower elections, but whenever it came for the presidential election, so he had won that and he became the most successful president in the history. So make sure that you will never back down. So struggle hard, struggle happily, and take enjoyment in the course of struggle. So do it all the very best. Good luck, friends.